Hi, ladies and gents. We're back. I hope you got some rest and you're ready for this second part of our video today. What we're going to do, guys, is we're going to talk about how rivers will start to meander when we get to lower gradients. There's going to be differences in velocity within the river itself. And specifically, we're going to talk about the difference between the outside of the bend and the inside of the bend, how that affects stream channel shape. We're then going to get into talking about, all right, what features can be formed by that? So we'll talk about sandbars, oxbow lakes, what happens when a river or a stream makes its way into a larger body of water, and what that deposition looks like. All right, so those are the main topics we're going to get into here. Let's focus in on an example of what can pretty much be our exemplar throughout this entire conversation. Okay, so we're going to focus in using Google Earth. Here we go. All right, here is the great state of Louisiana. Okay, and the borders are kind of coming up there a little bit slowly, but the border here between Louisiana and Mississippi is the Mississippi River itself. Okay, so if I focus in, here's a great spot for us to take a look at. All right, I want to bring this part into the main view here, and let's just take a look at this. So the river is flowing from the north to the south, but in this case, it's actually heading directly west and then coming back around almost to completely east. So this is a major meander loop. Now, what are some of the observations that we can make? Well, the water itself clearly is not clear. It's very turbid, it's jam-packed with sediment. Also, on the inside here of the bend, you just see this yellow. Can anyone guess what that is? We call that a sandbar, okay? And then on the outside, it's just not there. It seems like the water's deeper over there. So in this video, we'll talk about why that is, okay? If I focus out a little bit more, I make my way over here, something funky happened over here, guys. This is a lake. And these are like little islands there too, but it doesn't look like your standard lake. It's really narrow and it's kind of windy. Well, this used to be part of the river. It's called an oxbow lake, and we'll talk about that more too in this conversation upcoming. Let's get into it. Okay, let's make this full screen. All right, so I'm going to use my drawing skills. Hopefully it'll work out for me here. I'm going to move myself up this way, all right? And we're going to talk about what occurs to stream velocity when a stream starts to meander, okay? So I'm going to use white here, okay, and I'm going to draw myself, okay, a nice meandering stream that looks something like this, right? You know, not the same exact image as we saw before with the Mississippi, but this will work out pretty well for us. We're going to locate 3 different locations along this river. Let's use a different color for us to really focus in on those different spots. All right, so here's one meander bend over here. So let's make a cross section right there. We're going to label this A and this B. Then we make our way down over to this side. Let's label this one out, C and D. And let's try to find a spot in the river where it's kind of going straight. And I would say it's probably more down here. So this is pretty straight over here. So let's make this E and F over here. Okay, so why am I doing this? Well, let's talk about the velocity of the water, how quickly the water is moving. And let's talk about how that affects the erosion of the banks and also the deposition of sediment there. Okay, so let's start with A and B. Okay, so what happens, guys, is when water makes its way to the outside, okay, of a bend here, okay, like that, the water starts to kind of whip around the bend, right? If you've ever been like sitting in your car, right, and your mom and dad are driving pretty fast and they're on the highway and you're about to get off like an off ramp and they keep going fast, your body just wants to keep going in a straight line path and get squished against the door. And kind of works in the same way here, right? The water on the outside of the bend is going to have a higher velocity, a higher V over here than the water on the inside of the bend, which will have a lower velocity over there. Okay, so there you have it. So we learned before in the last video, if the river's going faster, well, what happens to the amount of sediment load? Well, if it's going faster, it's going to carry more sediment and larger sediment. So there's more erosion happening on the outside of the bend. We're going to use a different color for that. We'll see that this is E for erosion. Okay, And then there's more deposition happening on the inside of the bend. We'll call that D. Okay? So let's review the concepts again. Okay, let's go to CD. All right, it's opposite here. Well, where's the water going the fastest? It's always the outside of the bend. Okay, so the water's going faster over here, slower over here. Well, where is the deposition happening? Well, the deposition is happening on the inside of the bend. The erosion's happening, or that is dominating anyway, on the outside of the bend, like so. And then if we go down to EF, well, there's no outside, there's no inside. So the velocity is pretty much uniform going through, okay? So you don't have that erosion deposition dominating on either side, okay? Now, a common question you can get asked is, what is the cross section? What does the stream channel shape look like when you're at these different cross sections? So let's give you 2 or 3 examples of that. Let's go back to AB, okay? Go back to the red color. All right, here, so on this side of the screen, we're going to do cross sections. And I'm not going to go red, I'm going to go a different color. Let's just go white. Okay, so let's say here's A, and here's B. And here's the top of the water, like that. Now, cross section, another word for that is profile, if you guys remember that from topographic maps. So now you get in your scuba gear, you jump into the river, and you're actually looking at the profile and the shape of the stream itself. At A, there's more erosion, right? So if there's more erosion at A, the more that rock is being removed. So it's going to be deeper here at A, and then more gentle, more shallow at B. Your velocity is greatest here at A. Now, can you guess what it's going to be like at CD? Can you guess what it's going to be like at EF? Well, I'll tell you what, I'm not going to do those for you. This is going to be question, okay, number 4, guys, okay? I want you to draw me the profile of the stream bed for profile CD and for profile EF, okay? You're going to have to draw it. You can either do it on your computer. If you can't, guys, you're going to draw it on a piece of paper that's going to go along with your assignment for the first half of this week. All right, guys? So I encourage you to pause the video, go back, rewind what I just did, guys, and to review it in that way. All right? So let's move on, all right, to the next thing, all right, that we're going to be talking about here, guys. Okay, so we're going to erase that out. All right, we're going to get rid of these drawing tools here, and we're going to continue with that conversation of the Oxbow Lakes. Okay, so ladies and gents, if you have a river meandering dramatically, all right, these 2 meander loops here are going to get really close together. And then over time, they're going to end up touching one another. And when they do that, the water is not going to want to keep going around. It's going to take the path of least resistance coming through this way, and it's going to cut off those meander loops. Now, over here, guys, in this black and white image, you can see this really, really aged, old river system here, guys, and you see a series of oxbow lakes. Now, sometimes the water itself will evaporate away. There won't be enough groundwater recharge. There won't be enough rainwater to kind of make its way in. So it just kind of dies off and ecological succession takes place and it just becomes land again, right? But over here, guys, this is pretty much stationary. It looks like it's reached some sort of equilibrium and it's doing pretty well. This is one way a lake forms. Lakes can form by the movement of plate tectonics. Lakes can form by glaciation, all right, by the land kind of sinking beneath the continental ice sheet, causing large lakes like Lake Superior and the Great Lakes. And this is a third way that lakes can form. Okay, it's pretty funky, right? All right, so let's keep going. All right, so step by step, Oxbow Lake, meander loops get closer together. Okay, they touch, it gets cut off. It's as simple as that. Okay, now let's take a look, guys, at what happens, ladies and gents, when a river or a stream makes its way into a larger body of water. Let's stick with the example of the Mississippi River like we saw on Google Earth before, okay? Well, what happens, guys, is that when the water strikes the larger body of water from the river, okay, what's going to happen to the velocity of the stream? Well, you might have guessed. When the river is flowing into the larger body of water, it's like bang, it's hitting a brick wall, okay? And it slows down. When it slows down, what happens to its ability to transport sediment? But when it gets slower, it can't transport much at all. Deposition starts happening. And what you get, guys, is you get a delta that forms. A delta, guys, occurs at the very end of a stream or a river. Here's the Mississippi Delta. There's the Amazon River Delta. There's the Nile River Delta, guys. Okay, and these areas are, rich in sediment, and usually they're very highly populated. And this is more of a social studies question, or a comment, because they're usually hubs of travel and commerce usually. Okay, now moving on from that, when deposition happens, guys, and when the water slows down, there's something that occurs, and this is called the process of horizontal sorting. And your larger sediments, the heavier, bigger stuff like your cobbles and your boulders, will deposit first, right? They're heavy. They might have a higher density potentially, and they're just going to fall out quickly. Then cobbles, then pebbles, then sand, then silt, then clay, and then precipitates after that. And this is the process of sorting. Whenever you have an agent of erosion, deposition is going to happen in either a sorted fashion or in an unsorted fashion. For anything that's fluid, like air or water, deposition always happens in a sorted fashion. Okay, so wind erosion, well, that's fluid. That's going to be sorting or sorted deposition. A river, sorted. Waves or current erosion, that's also going to be sorted sediment as well. Very common question that you can see. Okay, in this case here, this is called graded bedding. All right, so if you're, let's say, looking at ancient bedrock or ancient rock strata, and you look at many different layers here, and you see a uniform pattern there, you know that a river was here long ago and deposited sediment. Then there was kind of a pause there that didn't continue. Then it started again. We call this process or this feature graded bedding. So down here we have conglomerate, then there's sandstone, then there's siltstone, and then it stops, and then it happens again. Okay? So anyway, really that's the last thing that we're going to be talking about together. All right, guys, in these screencasts of river erosion and deposition. I hope you enjoyed both of these screencasts, and I hope to see you all very, very soon. Thanks a lot, guys.